have our XPDRAINAGE team online today, and our presenter is Jefferys. Jess has over 9 years of experience with XP solutions, having specialized in tech support, training, and product specification. Jessica is currently the product owner of XPDRAINAGE, and so she's been shepherding its development over the past couple of years. Thank you for joining us, and welcome, Jess.
Thank you, Nicole. So for those of you who aren't familiar with XP Solutions, who don't know us already, we've got a long history of providing software that allows you to design and model with confidence. All of our software products are backed by our training and support service, which is provided by engineers around the world who have expertise in a range of areas, including sustainable drainage. And they're here to provide the support you need to succeed in your work. On to the agenda for today. So we'll be taking you through some of the new features in the 2015.3 release of XPDRAINAGE with some live software demonstrations. As Nicole mentioned, my colleague Zach Sample is online. He's going to be available throughout this webinar to answer your questions. So although we will have a question and answer session at the end, there's no need to wait until the end of the presentation. You can use the GoToWebinar interface to ask those questions as they come up. The 2015.3 upgrade is free for existing Expert Care customers who'll be receiving notification by email within the next week or so with a link to download the new version and the activation code needed to run the software. I won't have time today to run through all of the new features, but there is a full list available on our website. And if you want any more information after the webinar, then please do contact us to find out more. Our contact details are going to be shown at the end of the webinar. You should also have them on one of the registration emails you've received from us. So firstly, I'm going to talk about junctions. To enable you to design a more complete drainage solution, you can now include both simple junctions and manholes in your design. And we've enhanced further the automatic level setting for connections and junctions so that you can speed up the design process when you're using these features. We've also explicitly included bypass flows in a way that's more intuitive and more visual, and this means that additional surface channel flows can be more clearly represented and communicated, and is particularly useful for assessing drainage solutions that are designed for multiple return periods. We're continuing to extend the inlet capacity types available, and we've added functionality to include a saturated zone infiltration devices via the underdrain release height option. So this will hold water back in the filter area so that you can release it at a higher level despite having a low level underdrain. With more capabilities added to the design elements, we've boosted the validation report so that you can flag potential issues with levels, and we've also built in some automatic solutions, saving you time in iterating the design later on. Finally, we'll be reviewing our new comprehensive water quality volume report to show how you can demonstrate compliance with local runoff reduction requirements. So starting with junctions. Simply connecting stormwater controls together may be suitable for conceptual design, but more and more we're seeing the need to design a holistic model that includes the green and the grey infrastructure elements and accounts for the junctions, manholes and pipes that connect stormwater controls together. So you still have the option to take a conceptual approach, but you also now can go into more detail and include all those elements. There's two options available under junctions: simple junctions, which are typically used to join open channel sections or conceptual connections, and do not have user-specified dimensions. This means you've still got a quick model build option if you want. Manholes have levels, shape, and dimension specifications, and using templates for manholes can vastly reduce the time taken in model build, as it avoids the need to manually set depths and diameters. Together, these features enhance the existing pipe and channel functionality by allowing you to make connections where pipe joins, changes in direction or diameter occur, and where channel cross-sections change. The manhole and connection levels are automatically set from surface data if you have that available, to further speed up the model building process and get you more quickly to your first iteration of the design. These levels can be easily checked in the profile views, connection form, or by using the new validation tools. And of course, if necessary, can be edited or entered by the user as well as using the automated options. The new results summaries allow you to sort the junctions and connection forms to show the results either for all items for a particular storm event or for all storms for a particular item. You can also filter by a particular flow path. So if you're interested in looking at a particular route through your network, you can select this and see how the water passes from one junction to the next or one connection to the next. On the connections results, if we were to, for example, filter by all storms and select a particular pipe item, we could then look at the flow capacity ratio column. This is particularly useful because we can see in this example, for all average recurrence intervals or return period events, our pipes are running below capacity. It's a ratio, so it's the flow against the capacity of the particular pipe or channel. And if we were to see a ratio of 1 or above, this would quickly flag a potential area that needed to be investigated in more detail, as it might indicate that there's a restriction in the network and a place where we could look at upsizing a pipe or channel. So I'd like to show you some of these features with a live demonstration in the software. Here we've got a model which contains a number of simple junctions indicated with this icon here, and a number of manholes indicated with this icon shown here. The simple junction has been used in this case to connect two open channels because there's a change in the channel cross-section. If I open up the simple junction form, we can see that there's no need to specify any dimensions. They're set by default in the background. But we do still have the ability to have inlets and outlets. In this case, we have no restriction on the inlet and a free discharge on the outlet because we're using this just to allow us to change the cross-section of the channel. If we open up the manhole, we can see that we do have dimensions. In this case, we're connecting two pipes. It's a physical manhole that we're representing. And again, inlets and outlets can be included, such as an orifice outlet, which is restricting the outflow to the downstream pipe. Adding junctions to XPDRAINAGE is similar to adding stormwater controls. We can use the options available on the toolbox on the right-hand side and drag and drop onto the plan. Or we can use the build ribbon and add individual items. To add a series of manholes or other elements, we can use the add train option. If I select this, it tells us what the next item to be added on plan will be. And when we hover over the plan, it also shows us the icon. if I want to add a series of manholes, I'm going to select, in this case, a template that I've set up, which contains a 4-foot diameter manhole. Then I can just click and it will use the connection that was last selected. That's also highlighted on the toolbox on the right hand side, and I can right click to end the train or use keyboard shortcuts, the escape key, to finish my series of manholes and pipes. I could then look at these in more detail by opening the individual items, but it has also automatically created a train for me. This train produces a profile view, and I can see that because I have surface data and I've used a template for the manhole, my levels have automatically been set and there's very little work to do. If I switch to another version of this model, I can interrogate the result summaries in more detail. So I can look at the junctions, and what's being shown here is all of the items. So all the junctions are being shown for a range of different results. In particular, we may want to look at the maximum depths, the maximum inflows and outflows. I can do the same for my stormwater controls and for my connections. And as I mentioned in the presentation, I can look at an individual item and look at the flow capacity ratio or any other column that I want more detail about. Moving on to the next section, bypass flows are now more easily identified on plan because they're shown with a dashed line. So these can be differentiated from our regular connections shown with a solid line. In the stormwater control or manhole, the bypass destination is identified and different inlet capacity options can be used to specify how much flow goes into the manhole or stormwater control and how much goes down the bypass route. So in this example with the low, high flow capacity option for the inlet, everything up to 3 cubic feet per second is going to get into the stormwater control. Anything above 3 cubic feet per second is going to go down the bypass route. And our bypass destination, the connection that is receiving the bypass flow, is shown on the inlet tab. The bypass flow is also split out on the item results. So if we need to interrogate in more detail how much flow is passing forward to each connection, we can look at this on the results as well. We're continually expanding the range of inlet capacity options that are available, and the latest addition is the rated by flow addition. This enables us to specify an approach flow. This is the flow that is being received by the inlet, and a captured flow. So in this case, the captured flow is going into the stormwater control or into the manhole or junction, and anything above the captured flow is going to go to the bypass destination. If we don't set a bypass destination, that flow will merely be lost. It won't travel forward in our network. This approach may be specified by gully manufacturers and allows for more complex inlet types than were available previously. Because this is a spreadsheet, we can copy and paste data into the form, and we can also save this as part of a stormwater control or manhole in a template and reuse it. So the idea is you only need to set up your inlet types once and reuse them over and over again. Infiltration devices such as bioretention areas or permeable paving with stone fill, it may be necessary to provide a saturated zone that does not drain. I've circled in this diagram on the left how we achieve this in reality. And the blue line, the dashed blue line here, is showing where we want that saturated zone to be. Our underdrain pipe is at a lower level, but has a special setup in the downstream manhole so that we can not release that water until it reaches a certain height. This might serve multiple purposes. Sometimes we need to keep the vegetation alive. Sometimes we need to keep the filtration media wet in order for the pollution removal to occur as we would expect. The level at which this overflows, the blue line, and the top of this small capped connector is the release height that we can now specify in the underdrain section of several stormwater controls. So in this example, we have an underdrain in the bioretention area. If we add together the height above base and the release height, we have 2.5 feet, and that tells us the total depth of the saturated zone. Next, our new water quality volume report. So there are varying levels of detail required for sizing LIDs and demonstrating that treatment is occurring. The starting point is often a simple water quality volume calculation, sometimes known as the runoff reduction method. Including this in our new report, we now have the option to show that we've met local requirements, but also move on to more comprehensive analysis and reporting of connected treatment trains in the same package, i.e. XPDRAINAGE. There's two methods available for water quality volume. We have the runoff reduction method, which uses the equations shown here. This is included in the New York State Design Manual and the Atlanta Stormwater Manual, among other specifications, and also a simple water quality volume calculation, and the equation is shown below. In both cases, we can choose to either have manual user input of the area of the runoff coefficient or percentage impervious, or we can use plan data if we've already outlined the catchments in our design. Then, when we actually calculate the water quality volume, we get a comparison between the volume of each sub-catchment, the requirement, and the stormwater controls on site and the volume they provide. This is a really important feature for reviewing work and checking to see if we've met the runoff reduction requirement. The new report will tell you if you have been successful or if you failed in providing enough water quality volume in your stormwater controls compared to the target based on the sub-catchment areas or the manually entered area that you have. So we'll look at a couple of models to show some of those new features. Starting with the bypass flows, if we go back to our first demonstration model, as I mentioned, it's easily identifiable on plan with the new dashed line rather than the solid line, and can be added to any inlet, junction or stormwater control by the right-click menu. We could add a bypass connection, select what that connection was, and draw it on plan. We could also add it via the build ribbon by using the connection section of the build ribbon again selecting which type of connection we wanted to use. If I open one of these bioretentions, we can see that in the Inlet tab we have a bypass destination specified, which represents this connection, which is shown with the dashed line on the plan. This particular bioretention is using the rated by flow capacity type to represent how this inlet behaves, how it receives flow from the surrounding catchment. The approach flow part of the table has already been populated, but I have a spreadsheet here from which we can copy and paste in the captured flow. So any flow that exceeds the captured flow, for example, if our approach flow is 1.5, our captured flow is 1.4, that means 1.4 cubic feet per second is going into the bioretention and 0.1 cubic feet per second is going down the bypass. If we look at our other bioretention here, we can look at the new underdrains section and see where the release height is located. As I mentioned in the presentation, if we add the height above base, which is the height at which the pipe or underdrain invert level is, to the release height, we get the saturated zone level. So at 2.5 foot, the water will begin to be released. Switching back to our other model, we can look at the water quality volume. The water quality volume calculator is contained in the design tools because we can run this either prior to building anything in XPDRAINAGE, or we can run it after we've completed a design. If I open the form, you'll see that we've got the choice of methods available, the simple water quality volume or the runoff reduction option. Here we're using the plan data because our subcatchments have already been outlined in this model, which means we don't have to specify the areas again. It's actually reading data from the subcatchment information, such as the percentage impervious. And if we hit calculate, it's then giving us a report. First, it will tell us the breakdown of subcatchments, and for each subcatchment, what water quality volume we actually need to provide, as well as the total. Then, because we have stormwater controls already specified, it's doing the same thing for our stormwater controls. So it tells us how much volume we could contain in each of these stormwater controls and the total volume across the whole site. At the very top, the most important thing, we've been successful. We're actually overachieving and providing more water quality volume than we require. Moving on to our final section that we're going to look at today. As part of the validation report, we've introduced new options to give warnings for potentially incorrect levels in the design. This new system of validation provides suggestions to automatically update the levels where they may be incorrect. So firstly, the report tells us what is wrong with the design. For example, our invert level is greater than the connected invert level. And then it gives us a solution. So we could match the invert level to the lowest outgoing connected invert level. If we want to interrogate this in more detail, we can expand the table and review and open individual items. You may also find the profile view is useful for seeing visually actually what's happening. So the three things identified in that validation report can be clearly seen on the profile view. We've got an outgoing connection that's actually lower than our manhole invert level. Here we've got a manhole invert level that's lower than all of the connections coming into and going out from it. This may be valid, this may be a sump, but the report's just giving us a warning in case we want to make a change. And finally, down the bottom end of the screen here, we have a connection that has an invert level lower than the item it's connecting into. So if we had expanded the report, we'd have been able to see the locations where this occurred. And if we were to accept the solution offered by the validation report, the changes that would be made. So for the first two warnings, our manhole invert levels will be updated. For the third warning, our pipe invert level will be updated. If we accept those options and revisit the profile view, again, we can quickly see whether that correction has occurred. So I'll show you this in one final model. The validation option can be run either as part of the analysis. If we click go, our model will always be validated, or separately at any point during the design process. So our three options have been identified, and we can interrogate in more detail exactly what's occurring. If I open up the profile view, then we can see, as I showed in the presentation, where these issues actually occur. And going back to the validation report, if I accept all the suggestions and hit apply, our profile will be updated live, and our validation report will now tell us that there's no further warnings. This means we could then go and run the analysis separately or continue editing our model. So to recap, we've seen the new Junctions features and how they can be used to build more complex designs. Our improved bypass flow options, including more choices for inlet capacity, and the ability to use the under-drain release height to specify a saturated zone. We've also taken a look at the water quality volume report, which enables compliance with local design standards ahead of completing more extensive LID analysis in XPDRAINAGE by building a full design and analysing it for quantity and quality. And we've also seen the time-saving automatic updates available in the validation report. Thank you for listening to the What's New in XPDRAINAGE 2015.3 webinar.